In 2007, the U.S. Environmental Protection Agency dropped a bombshell that stunned the entire trucking industry. The new 2010 emission standards demanded an unprecedented cut in nitrogen oxides, from 2.4 grams per brake horsepower hour down to just 0.2 grams. That was a 92% reduction, enough to turn every diesel engine manufacturer into a racer against time. This wasn't just a technical challenge, it was a life or death test, forcing corporations to make decisions that could either save them or destroy them. While most competitors followed the familiar path of adding complex after-treatment systems, Navistar chose an entirely different route. They believed they had found a simple, elegant solution, powerful enough to reshape the entire industry. And from that bold decision came a name, MaxxForce, an engine that was supposed to change the game, but ultimately became a nightmare that dragged Navistar into the abyss. Under the crushing pressure of the EPA, most major engine manufacturers chose what seemed like the safer route: selective catalytic reduction. Cummins was one of the first to openly commit to this technology. Their solution sounded complex, but engineers believed it was feasible. By injecting a urea solution, known as diesel exhaust fluid, directly into the exhaust stream, the SCR system converted harmful NOx compounds into harmless nitrogen and water vapor. SCR was far from simple. It required an entire supporting system: a 20-gallon DEF tank, precise electronic pumps, specialized injectors, and carefully calibrated catalytic converters. Still, Cummins believed that despite its complexity, this was the most reliable path to meet the standards while preserving performance, durability, and fuel efficiency. Detroit Diesel soon followed suit, partnering with suppliers like Bosch to perfect their systems. Meanwhile, Caterpillar initially rejected SCR and partnered with Navistar to pursue another path. But just 2 years later, in 2009, Caterpillar decided to exit the North American on-highway engine market altogether rather than adopt SCR. That left Navistar as the only major player, still standing firmly against it. While the rest of the industry put its faith in SCR, Navistar insisted it could solve everything inside the combustion chamber. The answer was called Advanced EGR. In truth, EGR wasn't a new technology. It had been used since the 1970s to recirculate a portion of exhaust gases back into the combustion chamber, lowering combustion temperatures and limiting NOx formation. But Navistar wasn't satisfied with a portion. They decided to push recirculation levels to 35 to 40%, many times higher than traditional systems. This unprecedented leap required a complete overhaul of the intake system, massive cooling upgrades, and a rethinking of combustion strategies. On paper, the idea sounded irresistible. No DEF tanks, no extra fluid refills, no maze of external plumbing. For fleet operators focused on cost control, the promise of no DEF, no hassle, was a sweet offer. Navistar even produced comparison visuals, their clean, uncluttered engine on one side versus competitors' setups buried under hoses, tanks, and added components. CEO Dan Ustian leaned into this advantage. On conference stages, he didn't just promote Advanced EGR as elegant engineering, he openly mocked SCR as the wrong path. Ustian was convinced customers would grow tired of DEF maintenance and eventually realize Navistar was the one true solution. But beneath that confidence lay an enormous technical challenge. Feeding exhaust gases over 1,000 degrees Fahrenheit back into the engine placed crushing demands on the cooling system and material durability. To make it work, Navistar had to develop oversized EGR coolers and ultra-precise electronic control mechanisms. This was no longer a matter of tweaking an existing engine. It was a leap beyond known limits. And it was at this turning point that Navistar began pouring massive investments into the MaxxForce program. They transformed the Melrose Park, Illinois facility into a state-of-the-art R&D fortress, where more than 200 engineers worked around the clock to turn theory into reality. Hundreds of millions of dollars were spent on test equipment, emissions labs, and dynos capable of running engines under the harshest conditions. Navistar didn't stop at developing a single model. They rolled out an entire family of MaxxForce engines, from mid-range to heavy-duty. The centerpiece was the MaxxForce 13, a 12.4-liter workhorse producing up to 475 horsepower and 1,700 pound-feet of torque. It embodied the entire Advanced EGR philosophy, with sophisticated electronic valves and massive coolers unlike anything seen before. At first, everything seemed to be going according to plan. By late 2009, trucks equipped with MaxxForce engines were rolling off production lines. Navistar's sales teams aggressively promoted the engine's simplicity: no DEF, no tanks, no added costs. Fleet owners initially felt relieved, believing they had dodged the new burdens that competitors' systems required. On industry forums and at conferences, MaxxForce was hailed as the smarter solution, a symbol of American ingenuity. Inside Navistar, optimism ran high. They believed they were ahead of the curve, and that in just a few years, the entire industry would be forced to admit they had chosen the right path. But less than a year after the first trucks hit the road, troubling signs began to appear. The cracks weren't just metaphorical, they were literal. The most vulnerable part of the Advanced EGR system was the EGR cooler. It had to reduce exhaust gas temperatures from over 1,000 degrees Fahrenheit down to just a few hundred before the gases re-entered the combustion chamber. The enormous thermal stress quickly overwhelmed materials, even stainless steel. Welds and joints began to fracture under constant hot-cold cycles. When the cooler failed, the results were dramatic. Coolant leaked into the exhaust, creating thick white plumes that looked like a steam locomotive at full power. Worse still, some of that superheated exhaust gas forced its way into the cooling system, driving pressures far beyond normal limits. Expansion tanks swelled, radiator caps blew off, and collateral damage spread across connected components. Next, the turbocharger became the second major casualty. MaxxForce relied on variable geometry turbos with electronically controlled vanes. In theory, they provided precise airflow management to support EGR. In practice, the massive soot load in recirculated exhaust quickly coated the mechanisms, jamming their delicate parts. When the turbo stuck, boost pressure collapsed, power dropped, and the EGR system fell out of balance, driving exhaust temperatures even higher. A dangerous cycle began to unfold. Once the EGR cooler failed, the turbo was forced to carry extra strain and quickly weakened. Rising engine temperatures made the cooler even more prone to failure. Drivers recalled that after just tens of thousands of miles, they often had to replace both the turbo and the EGR cooler multiple times, an expensive and frustrating experience they would never forget. And these failures were only the tip of the iceberg. As the EGR system operated far beyond its design limits, a chain reaction of new problems began to emerge. The diesel particulate filter was one of the first casualties. The enormous soot load clogged filters prematurely, forcing active regeneration far more often than expected. Instead of every 800 to 1,000 miles, many trucks required regen after only a few hundred. During these events, power dropped sharply, thick black smoke poured out, and fuel consumption spiked. Some drivers even reported dry grass near their tailpipes, catching fire as DPF temperatures soared past 1,100 degrees Fahrenheit. But the DPF wasn't the only issue. Frequent regenerations also caused engine oil dilution. Late fuel injection used to ignite soot washed down into the crankcase, thinning oil viscosity. Factory spec 15W40 quickly degraded to something closer to 10W30 after just 5,000 miles. With weakened lubrication, turbo bearings, and other high-speed components were destined for early failure. The intake manifold, made of lightweight aluminum, also suffered. Moisture combined with sulfur in the exhaust formed sulfuric acid, corroding the alloy and leaving hairline cracks. Over time, these expanded, causing vacuum leaks, rough idle, and in some cases, complete engine shutdown on the road. For fleet operators, every breakdown carried massive costs. A single turbo replacement could exceed $4,000, not including lost time while the truck sat idle. Owner-operators were hit even harder, as repair bills often surpassed their monthly loan payments. The promise of simplicity and savings had turned into a burden, and at that moment, large fleet operators, who had trusted the promise of no DEF, no hassle, soon realized that real-world maintenance costs were far higher than competitors. Trucks sidelined for repairs meant delayed deliveries, damaged client relationships, and shrinking profits. Some major carriers reported that within just 2 years, a single MaxxForce-equipped truck had been in the shop dozens of times. The mounting repair bills and accumulated downtime left them with no choice but to scale back or halt purchases of international trucks. For owner-operators, the situation was even worse. Without backup vehicles, every breakdown meant lost income. Many admitted their monthly repair bills sometimes exceeded their loan payments. To them, MaxxForce wasn't a smart solution at all. It was a financial trap. The used truck market revealed the brutal truth. Dealers began refusing to accept MaxxForce-equipped trucks as trade-ins. When they did, the vehicles carried far lower values than comparable models with Cummins or Detroit engines. Some dealers bluntly admitted, if it's got a MaxxForce under the hood, it'll sit on the lot for a long time before anyone touches it. As customer trust collapsed, the fallout went far beyond sales. Navistar now faced a storm of lawsuits and political pressure unlike anything it had seen before. At first, the company leaned on NOx credits, emission allowances it had banked earlier, to keep selling MaxxForce engines. When those credits ran out, Navistar resorted to paying non-conformance penalties, essentially buying time by paying fines for every engine that failed to meet the 0.2 grams per brake horsepower hour NOx limit. This allowed production to continue temporarily, but it also made Navistar a lightning rod for criticism. Instead of fixing the problem, they were accused of stalling with money. By 2012, things worsened. A ruling from the DC Circuit Court struck down the EPA's interim rule that had allowed Navistar to keep selling EGR-only engines. Later that year, the EPA raised penalties from $1,919 to $3,775 per non-compliant engine. With tens of thousands of units shipped, the financial burden quickly became staggering. Meanwhile, class action lawsuits from customers began to surge. Major carriers like Milan Supply Chain Solutions and Dutch-made Logistics filed suits, claiming MaxxForce engines had fundamental design defects that caused severe economic losses. Hundreds of independent owner-operators joined similar actions. Industry publications repeatedly described International as a brand in a confidence crisis. Political pressure added another layer. Federal regulators pushed Navistar to adopt a real solution quickly, while competitors pointed to its failure as proof that SCR was the only viable path forward. Under relentless pressure from both the law and the market, Navistar had no choice but to surrender. By mid-2012, the company officially announced it would adopt SCR, a bitter reversal for a firm that had once mocked the technology as overly complex and ineffective. To pivot quickly, Navistar partnered with Cummins, allowing the ISX-15 SCR engine to be installed in its ProStar Plus line. The first trucks rolled out later that year, giving customers some reassurance that International was finally aligning with industry standards. At the same time, Navistar unveiled its own N13 SCR-equipped engine, a bid to show it could still innovate. Yet the late move could not erase the memories of MaxxForce's failures. Customers had already fled, and the market now viewed Navistar as the loser in a technological race. From that point, the true consequences of the MaxxForce gamble became painfully clear. On the financial front, Navistar plunged into crisis. Massive investments in Advanced EGR, followed by the expensive shift to SCR, drained its cash flow. Stock prices collapsed, investors pulled back, and credit rating agencies issued downgrade after downgrade. To Wall Street, Navistar was no longer a promising truck maker, but the poster child of a failed bet. In the marketplace, the exodus was unprecedented. Large fleets that had once purchased hundreds of International trucks shifted to Cummins and Detroit Diesel. Even the most loyal customers refused to take another risk. International's market share in heavy-duty trucks plummeted, giving rivals an even greater advantage. For the workforce, the toll was equally harsh. In 2013, Navistar was forced to close its Garland, Texas plant, cutting nearly 900 jobs. Other facilities shrank operations, employee morale collapsed, and International lost the sense of pride it had once carried. By 2016, the MaxxForce brand was officially retired, an attempt to bury a dark chapter. But the costly lesson remained, haunting both Navistar and the wider trucking industry. The story of MaxxForce proves a harsh truth. Even long-established giants can fall if they place the wrong bet on technology. Navistar once believed it had found a more elegant solution, but in the end, it left behind one of the most painful failures in American trucking history. But for us, this isn't just a sad story. It's a vivid lesson about balance. Innovation must go hand in hand with reliability, and every promise must be tested in the harsh reality of the road. If you enjoy behind-the-scenes stories like this, where technology, business, and human consequences collide, make sure to subscribe, hit the like button, and share this video so more people can discover it. Turn on notifications so you won't miss the next episodes, where we'll continue uncovering the shocking truths behind the machines that once reshaped the transport world. And what about you? If you were running Navistar at the time, would you have gambled on Advanced EGR? Share your thoughts in the comments. I'd love to hear your perspective.